Okay, here we go. So let's take a look here. Let's look at some rotations. Now, let's kind of warm up a little bit with the reflection. Remember, if I wanted to take like this blue triangle down here, triangle ABC, and I wanted to reflect it, then I had to create a line to reflect it over. So let's do that. We always use the axes, but I'm going to make a line here. How about if we go right there? Oh, that's not what I want. Over 5, up 5, how about right there? Perfect. Okay. All right. It's a little too, let's make that thinner. There we go. Okay, so there's my line. Now, but I have to, there's all different kinds of lines here that I could be using to reflect this thing, right? I could, for example, if I want to reflect it over the x-axis, that'd be kind of weird. Let's try that. So if I make that if I go to the transform menu and mark that as my mirror, then I can come down here. Notice how I did that. I just highlighted everything inside that triangle. Now I have to hold control and unhighlight the x-axis. So all I want is just the vertices and the sides. And if I hit reflect, look what it does.
Oh.
Okay. So it reflected it over the x-axis, right?
Now do it over the y.
Okay. Okay, if I reflect it over the y-axis, I can do that too. Right, let's go transform, mark mirror, and reflect. And there it is, right? Make sense?
Yep.
Okay. I could also, we'll do some more of that. We'll do some more of that stuff. But if I want to rotate something, I don't need a mirror. I need something else, right? If I'm going to rotate something, I don't need a line of symmetry. I need a point to put the thumbtack on, right? To rotate everything. I got to have what's called the center of the rotation. Drew, put that away, please.
Right.
Got to have the center of the rotation. And what I'm going to choose for the center of the rotation here, we're just going to keep things kind of simple for now. I'm going to make it the origin. Okay?
How bad will this affect our assignment grade if we don't do this?
It would be bad. You got to do these. I mean, it would be, actually for this unit, it would be catastrophic. Your assignment grade would not be good if you didn't do these. Okay, so I'm going to go to transform, and I'm going to mark that as the center. So the origin is the center. And now if I go back here, and I highlight this guy, and I want to rotate it, I can go up to transform, rotate, and look what it did. Okay, it said about the center, and the center evidently is point D. Okay, I probably should have made it O, but the center, the D is the origin here. Okay. If I want to rotate it about the center, then I can pick. I don't know what the marked angle thing is. I'm kind of curious about that. I should probably
just undot the fixed angle and see what happens.
Well, it's grayed out, so I can't do it. I'll have to look into that. I'm not sure what that even means. But for now, we don't care. For now, we're just going to pick an angle. So if I put in 90 degrees about the center, which is D, and I hit rotate, look what happens.
So that means it's rotated 90 degrees.
It went 90 degrees, exactly. So let's just verify that. Now, if I go, let's make this red so we can distinguish the two. So this guy, our new triangle, the image, right? We started with the blue pre-image, and we'll make the image red, just like they do in the book. Okay. Let's verify this. Well, for one thing, let's go ahead and label all the vertices of the image. Now, it's going to do that for me. If the original triangle was ABC, and I ask it to show the labels, what did it pick for the labels?
D.
No. What do you think it picked for the labels of the rotated
1, 2, 3.
Probably
A prime, B prime, C prime, which it should have, right? That's correct, because a rotation is a transformation. And remember, if we go clear back to the talk we had about 7.1, that's what we do. If we do a transformation on an object, then we take the original labels, and they just become primed, because prime in math means changed. We started blue and we changed it to red. Okay, but A is related to A prime, because A prime is the rotation of A, right? Yes, sir.
So if you were to rotate the red one again, so what would you call that? B prime too.
I'll tell you what, we're gonna do that actually, and you'll see. I'll answer the question. What it would be is it would just be a double prime. Let's put 2 prime.
Okay.
So which is just the same thing as if the A prime prime. So it'd be A with 2 prime marks.
So would you say A prime prime?
Either one, A prime prime or A double prime, either one. Okay, so now back on track, attention please, focus. Okay, so let's explore some of the properties of this rotation. What do you think if I wanted to, for example, measure the distance between the origin, and I'm going to call that, let's call it O for origin. Let's label this point, and I'm going to call it capital O instead of D. I just like that better. Okay, so there's O. If I measure the distance from O to A, and then compare that to the distance between O and A prime, what do you think? Okay, speculate that they're going to be the same. Let's find out. So I'll measure distance OA is 4.56, and let's make that blue because that's a blue measurement, right? Yeah. Okay. Let's measure the distance from O to A prime, and sure enough, you got it right. How about that?
Yay.
Okay. Now, it would be that way for all of them, wouldn't it? Wouldn't you agree that the distance between the pre-image vertices and image vertices and the origin is going to stay the same, right? Because we haven't changed that. All we've done is put a tack in the page and rotated the whole thing. Distance from the origin stays the same. Now, what about the angles? Let's do this. What if I measure the angle from A to O to A prime? What's that angle going to be? How much did we rotate the whole thing?
90.
So do you think it'll be 90? It will.
It looks, yeah.
It will. Okay,
What?
so the angle between,
Okay.
does that make sense? And let me draw those lines in real quick. If
Yeah,
I draw in, let's do it this way. If I go from there to there. Okay, so that angle that's formed,
I just didn't have the rotate back.
does that look like a right angle to you?
Yeah.
It is, right?
Yeah.
Okay. If I measure the angle, we'll just do one more, see if we can see if this continues. What if I measure the angle between B and the origin and B prime?
Well,
90 degrees. Not surprising, right?
not surprising at all.
Okay. Everybody with me?
Yeah, I'm with you.
So those are properties of angles, right? Of rotation, sorry. So we know that the points always are going to stay the same distance from the center, and every point is going to get rotated in an object by exactly the same amount, the amount of the rotation. Okay, what happens, let's try something else here. What if I put a point, let's just try a point. So if I were to take something like this point right here, let's say, and I'm going to rotate that guy. There he ends up, right? There's the original, there's the rotation. What if I'm going to put a point right on the origin? Okay, in fact, I'm going to rotate the origin about the origin.
Do it.
What's going to happen? I'm going to rotate that point 90 degrees about itself. And,
Oh, well, it's good.
it says only the marked center point is selected. The center cannot be rotated or dilated about itself.
Maybe we should highlight the.
And the reason Geometry Sketchpad won't do that is because if I were to rotate a point about a center, so if it's a point that's sitting right on the center, is it going to go any place if I rotate it? It's going to stay in the exact same place, isn't it? Right?
Yeah.
Okay.
Oh, shit.
Now I probably could if I move this point. Let's get rid of him. I bet if I do this, if I take that point and move it right over to there, maybe now I can.
Yeah, wouldn't that just be the same thing, basically?
Let's see something here. Let's see if I can rotate that. I'm just curious. Oh, it did it. Okay. As long as I drag a point on top of the center, it did rotate it. And where did it end up? Same place. Same place. Yeah. Pretty boring.
That's pretty lame.
Yeah. Oh, now look at this though. When I drag that point out, Yeah, see, the 2 points actually are there. They're 90 degrees apart. You see that? Huh, that's kind of surprising. Because I actually did put the point there, and I did rotate it. It's just that it ended up right on top of itself. Okay. Okay, next issue here. I want to do something else that's pretty cool.
Is it cool?
Yes, very cool.
So I don't understand how we do this. Like, I did the first assignment.
Okay, now watch this. I want you to notice something. This is really interesting. This is really interesting. Okay, I'm going to take this blue triangle, and I'm going to reflect it twice. Okay, I'm going to reflect it over this line right here, this guy. So this is going to be my mirror. I'll mark that as the mirror.
Did you do this last year too? It's just a new thing.
No, this is a new thing.
What did you guys do last year instead of this?
They drew it. Tell me it wasn't as fun. Okay, so there's the reflection. Everybody agree?
Yeah.
Okay, I'm going to go ahead. Let's make this green. Kind of in between. So the green is the reflection of the blue in that line. Agreed?
Agreed.
Okay. Let's label all these points too while we're at it. Okay, A prime, B prime, C prime. Now, we're going to do the same thing again. I'm going to make another line. Let's put a line, how about right here? Okay, and okay. Now I got that green line. Okay, let me ask you this. Just by looking at this now, can you tell me, could I have created the green triangle by rotating the blue triangle about any point?
Yeah. Well,
Could I have the green triangle is a reflection of the blue triangle in the blue line?
yeah.
Agreed?
Agreed.
Could I have rotated somehow the blue triangle about a point and made it line up perfectly with the green one? Think so?
No, I'm not gonna answer that.
Do you see a problem with that?
Yeah.
I don't see any problem.
There is a problem though.
There is one.
There is a problem with that.
Hello,
Joel.
Why didn't you just give it to Leia?
Oh, I don't know. You teach, let him teach, you know?
There, exactly.
See you later, Bruiser.
Where's Haley? Come on, pass it back. It's not going to work, is it? Because unfortunately, the green triangle is a reflection of the blue triangle, and you notice when you stand in the mirror and you hold up a pen in your right hand and you look at your reflection in the mirror, what hand is that person holding a pen in? Their left hand. Okay, because there's a left-right shift there, right? Everything gets your mirror image is going to be just like you, but it's going to be the left-right reflection, the left-right offset of you. So it's not really what you look like. It's actually, it's the reflection of you.
So what would
But other
happen?
people would see you obviously as being right-handed, not left-handed, right?
So what would happen if we actually showed it?
It's impossible.
Why is it impossible?
It would be an identical twin standing behind a piece of glass, because it couldn't happen. But anyway, let's not go there.
Okay.
So, would you agree though that the green triangle cannot be a rotation of the blue triangle because they're right-handed, left-handed? They don't match up, right? Okay. Did everybody buy into that?
Yeah.
Okay.
I'm kind of confused about the whole mirror. That's okay.
Well, that's really important that you get this though. So let me take a second and say that again. Hey, quiet. I don't want to get distracted because it's distracting me and other people. So everybody just listen. Raise your hand if you have anything to say right now. Otherwise, no, I'm not calling you right now. If there's a mirror and you hold up a pen in your right hand, when you look at the mirror, everything looks very much like you. If you measured the distance from the tip of your nose to that pen, it'd be the same in the mirror as it is in real life. The only difference is you get this horizontal shift, right? You get your right hand is the person in the mirror's left hand. And so you guys really don't overlap perfectly. If that person could step out of the mirror and stand next to you, they would be holding up the pen in the wrong hand, right?
Okay, gotcha.
Okay, so that's a property of reflections, that they do that. The same thing just happened here. And if I tried to take this blue triangle and I tried to, well, here, let's just real quick, let's just do it. If I'm going to try something here. I think this will work. If I just do that, clipboard, we'll try this. I really want to illustrate, I really want to illustrate this point. Oh, what's it doing?
Hey, wake up.
Oh, I can do this. I don't think I can.
Hey, do you watch Chuck Dynasty?
Apparently not, he doesn't have a beard.
Right.
Ah, okay, it did it. Wow, okay, so there it is. It kind of there. It's lined up. Are those the same size? Yeah.
No, they're not. Bigger.
Is that one a little bigger? Oh, it is.
Oh,
So you gotta make it a little smaller.
Nope, still bigger.
Is that pretty close though? I don't want to spend too much time on this. It is a little bigger.
No, you have to make it smaller. Smaller.
How's that?
Yeah. No, it has to be smaller.
That's right, actually.
That's pretty close enough, right? Okay, but I just want you to see that this isn't going to work. If I take this thing and I try to rotate it around and fit it up here over the green one, it's never going to overlap right, is it?
No.
No.
See what I'm saying? There's no way to make it work. Okay? Let's get rid of that. We don't want that thing. There we go. Okay, so fail. Now let's take the green image of the blue pre-image and let's reflect it over the green line. So now I got to go up here and mark this guy as my new mirror. And let me grab this one and reflect it. Okay, there it is. Now, what's it going to label this?
A prime prime.
There you go. It'll label, if I hit display, show labels, A prime prime, B prime prime, C prime prime. It's probably hard for you to see, but I can see it right from close up here. Okay, now, is the red triangle possibly a rotation of the green triangle?
No.
No, because they're also reflected. But think what we just did. Your reflection didn't work because the right hand went to the left hand. But then if I reflect that reflection, aren't I switching it back to the right hand again? Ah, okay. Now, is it possible that the blue triangle could be reflected onto the red triangle?
Yes.
I think so. So let's see if we can do it. If so, where do you think I would have to choose the center of the rotation to be?
The center.
Ah, okay. Well, now, if I'm going to choose a center of a rotation, it can't be an axis. It has to be a point. It has to be where I put the tack, right?
The origin.
Okay, now, it just so happens that... Now, are you picking the origin because it's the origin or because it's where these mirrors cross, the lines of reflection?
Where the mirrors cross.
Okay, I'm hoping you said it's because where the lines of reflection crossed.
Yep.
Because that seems like that might not be a bad idea. Okay, so the origin is going to be our center. And let's go ahead and rotate this thing, but by how much? Now I'm going to do a little experiment. I'm going to take these 3 points and let's measure the angle between the blue and the green line there. Let's just see what we get. So if I measure that angle from there to there to there, if I measure that angle, it's 90. Oh, it's off a little bit. I wonder why. 90.27. Okay, it's very slightly off. I wonder why that is. I must not have had that thing. Oh, there it's 90. There's 90. I just didn't have that thing stuck on the corner there. So it's 90 degrees. So the suggestion is I'm going to have to rotate the blue one how many degrees? 180. Let's try that. So there's my center. Now watch this. This is truly amazing. It's about to get crazy.
Andrew, quit talking. Quit talking.
Okay, so if I'm going to rotate this thing, 180 degrees about the center, watch what happens. What used to be a red triangle now has a blue triangle exactly on top of it. How about that?
That's crazy.
Okay, so
It's
what's the moral of the story?
Well,
Don't do drugs. No, that's good moral, but that's the wrong story. Okay, so what can we say about this? We did something strange there. If we did two reflections, right, over separate lines of symmetry, that was absolutely equivalent to a single rotation. But you have to be careful how you do that rotation. So two successive, in a row, reflections over different lines is equivalent to a single rotation of how many degrees? Well, now this was 180, but it didn't have to be. What if I had taken this point right here? I want you to see something. What if I had taken that point right there and I had scooted it over so this angle became something less than 90?
well,
Okay, then it changed where that triangle ended up, didn't it? And now my rotation didn't work anymore.
no.
Doesn't match up, right? So what do you think? Let's find out. What if I do a measurement here? Let's just see, let's go from A to O to A prime and see how far we rotated this thing, right?
Okay.
If I measure the, what did I do? A, O, first time, A prime, measure angle, there we go. What do you notice about those two measurements?
It increased.
It increased by
It doubled.
exactly how much? Within, obviously, these are rounded measurements, it only writes into 2 decimal places. But if you account for the rounding errors, what do you notice about those two numbers?
They're almost double.
They would be exactly double if it weren't for the rounding errors. Okay, so whatever the angle is between the two lines, I have to do a single rotation about the intersection of the lines of twice the angle between the lines. Does that make sense?
Yep.
That's always going to work. Okay, so if I wanted to rotate this guy, if I had wanted to do this again, and I could even, I guess I should have maybe not put that on the origin. I don't want you to confuse the fact that it just happens to be the origin. What's important is that it's where the where the green and blue lines cross, right? But if I wanted to change this, rotate this thing and change the angle, so I rotated it through exactly that angle, it would have ended up right on top of the red one. Make sense?
Yeah.
Okay, one last thing I got to show you, very minor. When I'm doing rotations, notice something here. Whoops, not that. Okay, if I want to rotate something in the counterclockwise direction, you may have noticed that what I did is I just rotated it, I put in an angle. So for example, if I want to rotate the blue,
So would it be a negative?
yes, exactly. If I want to rotate the blue triangle 30 degrees, look what it does. It rotates it about the origin because that's our center, but it rotates it this way. That's considered to be the positive direction. The positive angle direction is counterclockwise. And you all know what I mean when I say counterclockwise, right?
Yeah, it goes against the clock.
Yeah, it goes against the clock. Counter means against. And so this direction right there, whoops, this direction from here up to there is counterclockwise. If I want to rotate an object clockwise, that's actually considered to be the negative direction. And the way I have to do that on Geometry Sketchpad is, as you might expect, I would go transform, rotate, let's rotate it 30 degrees, counterclockwise, or clockwise. You got to put a negative in front. And then it rotates it clockwise. Make sense?
Interesting.
Yeah. Okay. All right. I think you're good to go.
You got it.